Good afternoon. I'm really surprised a packed house even at the last session of the conference. I hope you all have had a good dose of caffeine and or you've used toothpicks to keep your eyes wide open so that at least I get motivated with those open eyes. To start, I would like to thank Google for allowing me to come and present the paper on continuous integration here. And definitely, this marks the start of a new career for me because I know I'm getting filmed. So maybe Hollywood is not very far away. I've already reached the US. Maybe Hollywood next time. It's just a start. Here we're going to talk about simple tools to fight the bigger quality battle. And that is how we use the simple tools like task schedulers and patch files and the simple text files to get the continuous integration up and running and to use for our quality control system. So here's the agenda. But, during this entire course of the conference, we've heard different stories from the people who are right now struggling with the burden of manual testing, and they think that there is no way to come out of it, and they don't find any end to it. But in this presentation, we are going to tell you our story, and we are going to try and convince you that how can this be possible with the simple tools like the batch files, the task schedulers, which are at your disposal and very easy to use, and how you can get the return over investment, and the investment is just peanuts itself. And this is how it's going to be implemented and how we have used it for our benefit and how it could be used for your benefit without much of investment. So here's the agenda. We'll just introduce you to CI. How many of you are already aware of what continuous integration is? Oh, quite a lot. Oh, that's surprising. And then I guess how it works would not be of much interest to most of the people because you're already aware of it. And then we'll just specify about the challenges being faced and then how our solution was implemented using the simple tools. And then we'll have QA. And let me mention you, it's not the quality assurance. It's Q for question, A for answers. So to start off with, we'll just say hello to CI because, but as most of you are already aware of continuous integration, let me mention that all these definitions, I have not created even a single one of them. I've just used it from different resources, and Wikipedia is one of them. So just to put it in simple words, continuous integration is methodology in which the team integrates their work frequently and the builds take place, and there is they continually integrate with the different codes that have been checked into the subversion, and there is a mechanism by which tests are being run to check the integrity of the build. And the important part of continuous integration is that you get the response quickly and you get the feedback quickly whether the build was correct or not, whether it and it is done mostly by the automated tests which run through the build for every check-in, and then you get the response back. And here is the entire continuous integration mechanism, how it works. And we have used two virtual people here. One is Tim and one is Lisa. And now the important question is why we have used Tim and Lisa is because we didn't have Robin and Batman. I searched for it in Google Images, but I just got this image, and that's why I've used it. But the important thing that's missing over here is that the feedback mechanism that we get is through the automated tests, which is very important when you're having the continuous integration. That is how the entire feedback system works. That is, whenever a code is being checked in and a build has taken place, then there should be some automated tests to verify the sanity of that build. And the important part is that you should get the response back within less than 1 hour, because that's what was being mentioned yesterday, I guess, in I think Thomas and Mark mentioned that If you're getting a response, after more than 1 hour, then it's a symptom that your regression tests are taking too long, because you should get an immediate response. Immediate or within 1 hour is acceptable. So now I'll just hand it over to my Patrick, who's going to take you through the next slides.
Hello there, can you hear me? Terrific. Okay, why CI? Well, take you back to the situation that we're talking about at the very start of the story. We were dealing with a company that had a large number of software products, relatively speaking. In fact, it had more products than developers working on these things. There were even fewer testers, and the build process was effectively ad hoc builds when people felt the software was ready. So we're talking weekly manual builds, and these would be passed over to development, from development to testing, and given a kick around. There were no regular nightly builds, there was no continuous integration, and the control system was lesser known as the control system that worked on the check-out principle, which I don't know how many of you have encountered such a system, but it's really not much fun when you have multiple developers. So this was leading to an awful lot of late cycle heroics, and consequently late applications with poor quality. Challenges, well, but it's worked, it's done its job. The details of these applications, good point, all pretty much using the same technology. It was then Ball and Delphi, now CodeGear Delphi. Going for a third comeback, the comeback king. It's the Rocky Four. This is for those of you who don't know, this is a native code development tool for Windows, producing 32-bit executables. I'm guessing from the way that every other word is Selenium or Java at this conference that not everybody has experienced the joy of debugging and testing native code applications. They can go wrong in many, many more ways. You will probably have heard the phrase DLL hell. You'll have seen message boxes saying access violation and all the rest. These are all the things that just go away when you go to a managed execution environment. The point is that this is how the applications were. We need to eliminate those faults. We need to control the configuration management to make this problem just go away. And we need to know really what we're shipping. So that's Delphi. There were desktop applications. This is primarily what Delphi is used for. It can do other things. It can compile DLLs and that kind of thing in COM servers, but primarily they're used for desktop applications. As I've mentioned, the resources were few. Not highly technical, not trying to do people down, but I think what we're trying to say here is that the opportunities to suddenly down tools and say, let's all retrain in Python-based continuous build tools and use EasyB and that kind of stuff, that was not an option. Okay, as simple as that. We had a bit of a schedule to work to. So what we needed was a solution that was straightforward. I didn't want to impact testing and development too much by introducing too much stuff into the mix. It needed to be easily replicated. I think that's possibly a corollary of straightforward. And everybody likes a one-click solution. The batch files had no parameters. That's pretty much how it works. And easily configurable. This is something that Kamal goes on about a lot. Well, for the person who's doing the configuring, it matters. For everybody else, the idea was that they didn't care. So, the solution involved, well, no heavyweight client-server applications, no XML. That puts me perhaps on the edge of the spectrum. We just stuck with simple text files. It's old technology, works fine, not even anything as complicated as YAML. Previously, the situation had been that there were documents and scripting tools that would configure certain environments and set them up, but they were complicated, they were decaying somewhat in complexity, and the whole process could take days and perhaps be slightly manual. There was no need for this. Actually, CodeGear Delphi is a perfectly grown-up tool. There are command line utilities for everything, including their own pocket version of grep, which was really useful. So one of the jobs was to just create what just about every other good software project should have, which is the classics of make, install, make, configure, make, clean, that kind of stuff, and just create them and make them work. So one of the things was putting them all together. So that was it. The platform you do this on, I think, is quite important. Half the talks at this conference have been about the platform, suggesting that Groovy is the platform, or 90% of them. I think it's right. The ecosystem we were working in was Windows desktop development with plenty of governance of what people had already. So we stuck to the things you'll find on a Windows desktop. Batch files are perfectly fit for purpose for certain purposes. On top of that, you have the good old Windows scripting host, which you'll just find everywhere. There are some utilities you could find in the platform SDK, that kind of thing. And so we're walking up the complexity of the task into things that are getting harder and harder. And occasionally, you will need to do things like, say, export the proprietary binary format into a more human or source control readable tool. So we had people producing that kind of stuff. And I'll mention Colin Towers here. Hello, Colin. He was actually a consultant at the company, but he was helpful enough to write such a tool, which was bundled into the test process and used to transform the incomprehensible binary files into something that was CSV format and just could be eaten up by any sort of analysis tool. So why did we do all this configuration stuff? Well, because configuration management had been a problem. There was a certain amount of DLL hell. I didn't want to fix one problem by fixing configuration management and then introduce another by bundling a whole bunch of dependencies and other tools onto the developer machines, the test machines, and the automated test machines. So we came to the policy of having a simple platform and basically defended that as much as possible. So we created the continuous builds off the standard build process. That's fine. So you can now make the application. The next step is how to identify it. There's little point in identifying applications via a fairly meaningless ID. We previously had, as I mentioned, this little known source control system. The other branch of the company is already using Subversion. Actually, can I ask a quick question here? Is anybody not using Subversion in the room? Okay, for those out there in the audience, that's actually some hands, so maybe 10, 20%. Now I know. We chose to use Subversion. It works fine for an application that is primarily manually edited source code. There are no code generation steps, something like that. So you can just check out, start working, and off you go. And as a consequence of using Subversion, I don't know if people have had the experience of going from a check-in, check-out model where you check out a file, you lock it. Your colleagues can't edit anymore. Then you find you need a reference modified, so you check that one out. Pretty soon, you've got the whole application checked out. Your colleagues can't do anything. This was leading to people implementing workarounds to get their code checked in. That's not good. Subversion has the alternative model, which is just check out, modify, commit. If you commit and it wins, then you're there. If not, there might be a merge process or maybe a conflict resolution process, and you carry on working. This made a big difference to the performance of the team. With little impact on their development process. It, in fact, improved it because they didn't need to implement the workarounds. So we chose Subversion, pretty much followed the recommendations from the Subversion manual, branches and tags and trunk. The build process, it was a requirement that it should just work with branches and tags and trunks. There's no special locations. There's no reason to do that. We didn't do it. This required a bit of effort to support that, but it's worthwhile. And finally, kind of a policy that there should be a no excuses approach to configuration management. It should just work. I don't know, people have had experience in other organizations, but you might have found that a developer can do something, and when you install it, it doesn't work, or vice versa. We've had situations where it was an accident of fate as to which version of a DLL was being used by the application. This can have a big impact. At least 3 or 4 bug reports filed on that one. The solution was make the build script that builds application from source control just fix that problem by putting it in the right place. That's the upside of DLL hell is you can always put the DLL in the application private directory, you're back in business. So having done that, we have continuous builds. We also had the opportunity to do nightly builds. The next opportunity was that, I don't know if you know this, but Delphi builds very, very quickly. None of the products took more than, I don't know, 45 seconds to build. So we could build every revision if we felt like it. So we chose to. The benefit of that is that you can track down the provenance of a bug like that. A minute after a compile error is committed, the relevant person is notified by email and their team. And you wouldn't believe the difference that makes to the quality of people's check-ins. So we have these continuous builds. We've done some good to the quality of check-ins as far as compilation goes. The next step is to do something with these builds. It's no use having binaries just sitting around. I mean, disk space is cheap, so we were keeping them for, I think one project kept them for 9 months until they ran out of disk space. So you've got the opportunity to do a binary search on that bug if you feel like it, and I did that a couple of times actually. Something subtle crept in and we found it eventually, and that saved us a lot of time investigation. But ultimately, you want to do something and ship these builds onto test machines. And that was the next step. So here's a diagram. Testers and developers, we already kind of had the, testers contributing to the source code. There were some unit tests written in the same language that were maintained by the development team, the test team. And it's half and half developers and testers. So we thought we'd carry on with that approach and well, expand on it. Just take it to the logical extreme, which is that basically developers and testers were checking out the same source base. I know Pete Schneider seemed to mention that the same approach is adopted in some of their teams with the way they store their source control for their tests, so that when you tag it, you know what you tagged, you know what you tested, you know what you built. That was essentially the approach there, and there's nothing clever about that decision. It's just to make it as simple as possible, because again, it was a small team, not everybody knew everything, and the idea was to capture as much as possible, make it a non-problem, so people can get on with their job and their lives. So, developers and testers are simultaneously working on application features and maybe test scripts, that kind of stuff. Testers have access to a build at any time they want, if they feel like it. They can also do experimental stuff by rewinding the subversion revision, backwards or forwards, to maybe find a thing. And developers, in principle, of course, have the ability to confirm that the user acceptance tests work before they commit. So you don't have that breakage in the tests in the middle of your project, which makes a big difference. So that's step 0, 1, and 2. A repository has a post-commit hook, and that's where you can make all the magic happen. So what it was doing was effectively submitting something to a queue for a build machine, and we are the free server at the time, which is 1.0, is a fine achievement. To have a simple build machine for each product, why not? There was no complicated build process to actually put these machines together, and that was beyond our skills, to be honest. Instead, what we had was a simple build machine, the instructions for creating it, which is a one-page document, because it wasn't complicated, and then you run it up, and you plug it into the repository post-commit hook. When the build appliance builds something, which is not all the time, then it'll submit that build, if configured, to the test appliances, which is again tied to each product. So what happened is everybody's got a shared source control repository, because there was a shared framework. Somebody commits to application A, it's a check-in. This goes to all the build appliances, because there's a shared code, remember. Some of these will update to the latest repository ID, and some of them may find that their code has been changed. That was the trigger for running a build to see whether something had happened. So this actually counted one of the problems that we had, which was that we had one developer who was working on the same framework. However, his changes affected 3 or 4 applications, and it happened that actually for configuration reasons and other trivial stuff, he would check in a change. He knew it worked on his machine. However, 2 applications failed to build. Rather than finding out 6 months down the line when you have a go, we found out half an hour later. You go in there, you fix it, so that discriminatory power to find out what the impact was of the change was very useful. It's really a form multiplier. So we've built our builds per application. Now we pass them on to appliances. These run their test. and then we report back by email. As simple as that. In the good old days, when there were a few tests and they were quick, you'd find out gross errors within 10 minutes, which is not bad going. I would submit. So that's just the process steps. Nothing magical about that, really, as I described. And now I'm going to hand out to Kamal. Kamal was a developer, sorry, tester. I'm the developer. Yeah. And she'll go through what she understands about this and proselytize the process.
What I understand about this is this blank page, actually, when I started off. But then slowly and slowly, I got into the groove and I got more groovier. And then I started understanding it. And I can see a very active, wide open, wide eyes audience here. Do we have the sprinkler system here so that, you know, it could be used to, just in case, you see? Well, if not the sprinkler system, if it doesn't work, then as a tester, I have a backup. I have some special effects that could be used in case. Well, let's get back to the presentation. So we're talking about the main pillars of our solution, as it has already been mentioned by Patrick. So you can see the main pillars of the solution were first the subversion, because as a tester I would like to divide all things in different sections and different pillars so that it's easier for my little brain to understand. So first was the subversion repository. Yes, I did understand that. Then were the build machines, which were really, really important, because if you don't have any build machines, remember, we don't get any builds. So builds are important, and build machines are also. And then, yay, this is the latest discovery that we have. You know, everyone is talking about VMware virtualization, and yay, we used it. We used the test machines, we used the VMware. And then we have world's greatest invention, the VB Send Mail utility. I would say it is one of the world's greatest invention, because I don't know if this email wasn't there, I couldn't imagine our lives. Because right now, also, even if the presentation is going on, there might be many people who are going tippy-tappy on their laptops, just checking their emails. You know, it's just a human habit. Even after every 5 minutes, we'll just go and check our email, just in case anybody has sent an email, just sitting idle. So yes, these are the different pillars of our entire continuous integration process, and how we used the task schedulers to bind all these different pieces together, all these different pillars together. And in the following slides, I'm going to talk about how it was being done on different machines. And it was just done through task schedulers and batch files. So, you know, just like you have, in order to teach a child ABCD or 1, 2, 3, you know, you have to keep on telling him. He goes to the school, the teacher tells him A for boy, C for cat. When he comes home, the mama tells him A for apple, B for boy, C for cat, you know. And the main idea about is that in order to make anyone understand the value of some good thing, you have to reiterate it. You have to tell it 4 times, 5 times, so that the person understands it. And that's why we are reiterating the entire thing again and again. So as we have already talked about subversion, which is our pillar number 1. So, you know, just out of curiosity, is there anybody in the audience who would like to think about how we would have implemented our continuous integration using the batch files? You know, just give it a thought that if you were a person who were trying to implement it, how would you do it? What would you like to have it on the subversion repository? Because I've just mentioned that there are 4 pillars. Now there should be a way or a means of connecting them together. So how would you do it? Suppose it's your organization and you have to do it. Do you have anybody who's trying to take a wild guess? Even, you know, making someone stand on the machine and ask him to, you know, ask for everyone's code, then putting it manually on the subversion machine. That's a very valid idea. Sorry? On the Windows we are talking about right now. How would you do it? You hit the point. So here is what was the thought that was going in our mind, that we needed the post-commit hooks, because that was very important. You know, how is it triggered? When you commit it, the entire continuous integration is kicked off by your single commit. When you commit it, there should be some post-commit hooks which are able to take those, the revision numbers, and they're able to copy it somewhere, because that is the first point that is the first point where you need to start. So yes, you got a very valid point that you need to have some post-commit hooks, and what it was doing was it was copying the build markers. And then definitely, because it was all done through because now it's separate, it's a single machine, that is a Subversion repository. Now we need to have something which copies the revision or the code from the Subversion repository to the build machine, because it needs to be built. So for that, what we did was we were having the scheduled tasks that were running after every 10 minutes, and what they were doing were, they were just polling to check for markers, and these markers were nothing but the build revision numbers, and that were being generated by the post-commit hooks. You commit something, and a revision number, for example, R123 or R whatever is copied in one of the folders, and then there is a task schedulers which is continuously polling that folder and checking whether that any file is there or not. And once it finds a file, then it just kicks off the script to pass the machine names from the TXT files. And then again, because it's now just on the Subversion repository, that marker has to be moved onto the build machine. So the task that needs to take place is copy the markers from the repository to the build machines, and then just fire the scheduled tasks remotely. Now, once it has been copied to the build machines, you need to fire up the tasks there to build it. It's very fast, guys. Okay, so now just as we have now stepped from the Subversion, which is here, to now we need to go to the build machine. Now, what would you as an implementer like to have on your build machines? Because now we have done one part. We have just placed everything on the Subversion. The Subversion repository had post-commit hooks which had generated the markers, and it had copied the markers to the build machine. Now, what would you like to have on your build machines? Any ideas? Here you go, very important. If you don't have it, you're not going to have it. And that's yes, that's really important, because you need to have a mechanism to build the revisions that are in there. And those build marks, sorry?
Correct?
Yes. Good. Anything about the task schedulers, because now we have implemented everything through the task schedulers, then you would definitely have to have some sort of a scheduled task running which would check for the markers there, because the whole thing is working through polling on certain folders, and then it would check if a revision number is there, then it's going to build it. So this is so these are the three things that you would like to have, or which were there on the build machines. They were the build scripts. Yes, they had to be kicked off, because if you don't have any build scripts, you're not going to have any of your products, and then it's not going to be tested, and we need to test it. So they were build scripts, and then there were the scheduled tasks, which had to be, as I mentioned, it was polling the folders for the revision markers, because it needs to know which revision to build, right? So the revision markers that, remember, it were being copied from the Subversion repository by the post-commit hooks and the scheduled tasks that were there, and then kick off the test scripts. And then the important part over here is now the revision is being compiled, it's built, and it's there. Now the important part is, you need to test it, because it's continuous integration. If you're not testing the validity or the sanity of the build, or run the automated tests against it, continuous integration isn't very helpful. So you need to copy the markers. Now, once the revision is built, now you need to notify the test machines that, hey, our build with this revision is already there. So you need to mention that. And they were you can see that they were copying the markers to the test machines, and once the revisions were built, they were copied from, they were being archived to the done revisions. And you would really appreciate it, because at any moment, if you wanted to build any previous revision number, it was just a matter of copying that simple file with the revision number from the done revs to the build revs. And then the config files, which were the text files, because remember, we don't want any XML files because, as it was mentioned yesterday, XML have those pointed things, remember? And testers don't like pointed things. We hurt ourselves. So we were using the text files for that. And the text file was containing the information about what test machine on which the markers to be copied, and what tests to be run, and the type of release, which is mostly forgotten by most of the organizations, is the type of release on which you want to run the tests, because all we are aware of is just one type of release. That's, the release type. But we could have highly instrumented versions of a product also, because we would like to know the code coverage also, as it was mentioned in the earlier talk. So this, the configuration file that we had, you could just change the type of release, then it would just copy that particular release, and then the entire test would be executed on the highly instrumented build. It was as easy as that. So you can see the type of the configuration file here, and you can see this is the type of the release. You could have a debug over here, which means that it is going to copy the build, which was built, the install set or the build from the debugger folder, which was separately created, and then this the second part is the test machine on which it needs to be. So at any point of time, if you wanted your test to be run on, suppose, Japanese OS or Japanese Vista or Japanese XP SP2, then it was just a matter of putting that machine name over here, and it was the type of test that needed to be run, because definitely you don't want all your tests to run on all the operating system. Only a subset of tests might be needed for certain operating systems. So this was also taken into account, and you were specifying the three parts to it. Oh, that's not the special effect I was talking about. So now we have got everything set up. Repository, copy the markers to the build machines, and the build machine had to copy the markers to the test machines. Now, what do we want on our test machines now? What's important? Any ideas?
The build.
Good. And the tests to be run. So both of them should be present. Here you go. So the test machines had all these parts, the automated test scripts, which are really very important. Trust me, if there are no automated test scripts, nothing is going to run. And in order to write your automated test scripts, you need to have some tool. And they should be scheduled tasks. These scheduled tasks were really important, because after every 10 minutes, because a build marker was being copied from the build machine to the test machine, so the schedule task was continuously polling that folder to check if there is any build available for testing. And once it was available, then yes, the batch files were there to kick off the tests there. And any automation tool, this is really important. And this automation tool would generally be kicked off through the command line. And I guess almost all the automation tools have the facility to be kicked off through the command line. No, these are the functional tests. No, on the test machines. So these are the functional tests that we are talking about. And the configuration file that I had mentioned in the previous slide, they were containing the name of the functional test. So unit tests, well, you could have your unit tests run during the build time if you have your unit tests, but we were not having unit tests at that time. We were just having the functional.
One of the products had so we've talked about how there's lots of manual testing, and the build process was quite ad hoc. That was a consistent picture everywhere else.
And the important aspect was now, after the tests are being run, the people have to be notified about the results, because if everything has been done and you have got no notification, then what's the purpose? Because as I said, the feedback is very important. And how do you provide the feedback? By the world's greatest invention. And trust me, this is the world's highly complex, not easily implementable send mail utility. Well, any resemblance to any person living off or dead is highly coincident. It was no intention of putting any real person, living or dead, here. And if somebody wants to sue me, it's all Google's fault. When I searched for confused, this was the first picture I got. So anybody wants to sue me, sue Google, please. So with that, I would like to hand it over to my friend Patrick, who are going to reduce this confusion and would just take you to demo. Otherwise, the mind would explode as you saw the special effects.
I don't need that phone. Still hear me? Great. So I have to recover from maligning your current president. Right, so it's Kamal's brilliant idea in the dying minutes of this talk that we should have a live demo. The demo gods have been roughly with us in this conference, have they not? And I'll just go through what it's going to do. This is a very, very cut-down version of the kind of thing we were doing before. Kamal's been through the whole fact that we were using, you'll have spotted we were basically using a folder as a glorified queue to store data. We didn't need to get any queuing software for that. That's the whole point. It's also easily maintainable by people. You don't need to have the queue maintenance client. It just works. That's one element. The other thing that I think was worth mentioning is that because everything was asynchronous, the thing was quite elastic. If there was a flurry of activity, okay, you got your bills and your test notifications a bit later, so what? It wasn't that critical. But it was important to know what was going on, because when you're in the process of improving the code base, you'll be breaking it. It was already quite broken in the past, so you'll be finding things out. So that was the aim of having something that was going to be definitive as to when problems occurred, but the exact timing, and we're not so worried about the hour and 15 minutes. It was quite timely in most cases. So I won't read that out for you. But something that illustrates the basic principles and will create you your how can I put it, your canned continuous integration environment with minimal requirements will output something into a root folder with all the things that you would need. You're going to need all those good scripts. You're going to need a repository. And you're going to need a pretend build appliance and test appliance. Later, you could pick them up and put them on your virtual machine, and off you go. Now, here's where we get to the fun stuff. Cancel this. Try to. There we go. Ooh, it's struggling. And there's a reason for that, actually. We've all been talking about VMware so much. I thought it's time to see one. Right, bear with me here as I crick my neck. Where's my mouse? Here it is. Okay. A bit of thrashing on the laptop. Still, it is a testament to the tool and the power of the machines nowadays. So, first I'm going to go to here. Bear with me on my lack of experience with American keyboards. Okay. And I just need one of these. Is that there? Good. Right. Everything should be testable, should it not? So this itself has a test. That was actually a requirement. I was asked by somebody who was kind of a product manager at the company, how do we debug this, Patrick? And how do we set it up? So because the whole thing was very simple, I mean, there wasn't much to it. It was quite straightforward to abstract it and have the bootstrapper for the bootstrap, which would check out your template. And then the aim had always been, because as I mentioned, we have more products and developers, the aim was that you would have a little menu of products that you can have a look at today. And so he wanted some visibility on that. So let's have our temp bootstrap. Those aren't errors. No, they're not. I'll run it again, yeah? It's because I started from a clean state, and I don't know how to remove that warning message, sorry. It's got two options, again for debuggability, because remember, small team, we don't have a dedicated build team, whatever. You might have somebody who's more knowledgeable, but ultimately, each product team kind of needs to know how the stuff is built. So I passed out the parameter. I'll just prove it does work, yeah? Okay. So no. There we go. So it verifies a few simple things. There's nothing particularly clever about that, and the checks are really dummies just to prove that you could do this kind of thing. This is really sitting on top of some of the good features of Subversion. One of the good features of Subversion is there's another product called Tortoise SVN, which is really great. Again, back to what we were doing, which was Windows development. It fits in so nicely into what you need to do. So that was the location where this thing was set up. Tortoise SVN can just simply plug into the file protocol. So I don't need to create a service. I can just get started by looking at this straight away. So I'll show you what we've done. Using 6K of batch file, we've got this. We've got the startings of a project with a standard layout. There's a text file. That's, I guess that would be our to-do list or something. And we stored it in trunk. Later we'll branch and ready to ship. The automated tasks have already started, so I'm just going to simulate some development activity at this point. So I'll rename. And I will decide that was a mistake, so I'll revert it. And to illustrate another feature, which is that we had a shared repository for everything, I'll simulate the inception of a new product. And there we go. Does that make sense? I love this tool, actually. I don't know if you've used it, but there's a syntax highlighters file which has syntaxes for things like Pascal, so out of the box. A lot of the autocomplete suggestions for the function you've changed would be correctly spelt just by typing the first few characters. It's a godsend, really. And there's nothing to stop you extending that to other text files. OK, so not to say it refreshes correctly, but nothing's perfect. So we've done that. I've created a few revisions. And in the background, you've seen a bit of flashing, which is our scheduled tasks doing their stuff. So what are they doing? Let's have a look. Here we go. The additional flashing, the observant will have noticed, would have been the post-commit hook. Because I'm running it via the file system access API, it just runs the post-commit hook in my context on my user login, which is not great. So ultimately, for a proper system, you would use a service. But hey, it's just a demo. OK, so let's look at the build appliance. Fingers crossed. Oh. Has it run yet? Oh, there we go. So
It was the post-commit hook.
did you see that? What happened was It told us it was updating to revision 4, 5, and 6, and it decided to build for 4 and 5 because it was monitoring the file updates. When you're just continuously updating your checkout, you can just do that, and that works perfectly fine for an indicator there's been code check-ins. You could argue that if you allowed revisions to slip in there, you're in a problem, and maybe if people are generating files, then there's a conflict in update. That would be an issue, but the way to solve that, I think, is to have a simple policy on where generated files go and don't have people conflicting on the same file area. That's the fundamental problem you need to attack. It's a social issue, not a technical one, I would say. So we've done that, and now I've completed those. What's really interesting, of course, is that because it knows what was important and what wasn't, we have builds for 4 and 5. That's great. And then the next step, which I don't think we've seen yet, I'll just hurry this along because time is pressing on. It's tested 4 and 5. And we can go and have a look at that if I hadn't closed the window. And we'll find that there's a pretend marker. Now, all one has to do is just implement the bits in the middle, which are compiling your product and testing it. It's as simple as that. Of course, in the case when you've got 6 different products, actually, you have to do that anyway. Yeah, we're not talking about a single product family. We're talking about products that are constantly being created. I believe there's another one now. They're all being folded into the mesh. And when you have quite a strongly shared source space, but necessity of having not so many developers, you are obviously updating each product in a serial manner and then moving on to the next application and then moving on. So this shared source space and the shared concepts and the shared tests, and some of them produced file output that was used by the other application. You do actually have this linkage between everything. So it's important to bear that in mind and try and support the ability to, with your limited resources, get the job done and keep everything working. Yeah? We went for a situation, I believe, where a lot of things weren't working. The source couldn't be found, or when it could be found, didn't quite work properly because there'd been confusions about source control. By being strict on configuration management and then finding a way, I think, to easily deliver it to various people, including consultants, including testers and developers, you can just make the whole process more visible and identify problems and get there. Now, further work? Further work would be probably almost every other talk that's been presented at this conference. But this is what was done in the first instance, and it's the start, and you can replace all these parts with something better. For instance, we haven't talked about this, but there was a track instance that was producing RSS feeds, and a browsable view onto the version folder, and we plugged in a full-text search on every file and source control system using Microsoft Index Server, which means it can search the Excel files and the Word documents. Yeah, so you're now recovering some information you never had before, because good luck doing that on a shared drive. This stuff was quick and efficient. We implemented a web-based, bought-in bug tracking tool, which had two-way integration with the check-in. So when you checked in a bug, you mentioned it in the commit comment, it would put that into the check-ins for this bug entry in the bug tracker. So you could go backwards and forwards and see what's happened. Again, increasing visibility. Continuous integration is fine. I think if you don't actually have a lot of visibility, it's not so good. Kamal's talked about the pointy bits. We've been maligning XML very much here. But there is a serious point here. I did some experiments with branches and merging and tagging. And the problem is that branches are fantastic for having a good, sane release process. But if you have issues where people are quite validly saying, merging is hard, I have to do lots of manual editing of conflicts to resolve stuff and get it back into try and call into release branches, they will not do it so much, you won't get the benefit, or they might make mistakes. So I specifically went looking for file formats that, it's per line. The Subversion automatic diff just loves lines inserted and deleted. I also specifically tried to make sure that there were start and end lines, because I don't know if you've tried this, but adding lines on the end, Subversion really can't decide who did it. So make sure there's something already on the end, and then everything will just work automatically. Have them put it in the middle. That kind of wins. XML, I found that it would struggle. I think the users would really struggle identifying the conflicts when they did happen. It seemed also that the conflicts would happen more often. I'm not quite sure why. And finally, we had some XML configuration files that one of the commercial products used, which would constantly be rewritten in a different order depending on trivial changes to the project configuration, which meant you were looking for conflict city when these things were merged in. So we had to actually put some special steps in to massage these files and try and keep them unmodified as much as possible, and maybe train people to, like, you know what, don't change that. Let's just get it right once and save that. And the idea of this was just to make the merging and the branching process and the differencing process as seamless as possible, again, so we can release ourselves from worrying about source control and continuous integration and the rest of it, and just get onto the work. So those were our motivations. That's what we did. And I think that ends my section of the talk.
So I hope you had quickly understood the little big system that Patrick had created just for the demo, and how these three task schedulers represented the task schedulers that we had on different machines, and how these batch files, as you're seeing here, represent the batch files that we had on different machines and that we had mentioned earlier in our presentation. So let's get back to our talk again. And how do we do that? Cool. Okay, so this machine is very fast, I must tell you.
We're punishing it with that VM
yes.
instance, I'm afraid, so apologies to the audience.
Yes. So we'll just quickly skim through our presentation again, you know, just in case you forgot anything or you missed out anything, just scan through it. Oh, that was the special effect. Yeah, it worked finally. Yeah. So
in case it didn't work.
Yes. So it's all been demoed. I just kept in handy, you know, because the sprinkler system doesn't work, and last talk of the presentation, and people are just feeling the burden of so many talks, so much of information to absorb, and all going down. So yes, any questions? And I have actually crossed that out, that I will not take, I'll use Google before asking dumb questions, because none of the questions are dumb. Yeah, so many questions, I'm delighted. Yes?
So I can name 3 continuous integration systems that are web-based, network accessible, open source, that do largely the same things that you do. You know, some more features, some other features. Why did you not go off of existing work? Why did you go your own?
Well,
And by the way, their names are Cruise Control,
Hudson,
and
Team
which
City.
is not open source but free to use. So
yeah, no, you're absolutely right. Why didn't we do it? Because we did it in extremely small steps. Each one requiring a certain amount of proselytizing and massaging and explaining of the features. We didn't have a big bang say, you know, we're just going to stop for a month, and we're going to take all the stuff where we have this folder where there's archived object files that are linked into the application. And we're going to throw that away, and we're going to find where the source is, and then we're going to have a cruise control, there's going to be a web server, and blah, blah. That didn't happen that way. The sequence of events was start using Subversion, full stop. Then, as a consequence of that, the thing was, let's find the source, shall we? And then there was, let's have some continuous builds. So we need to make use of the build process. And then it built up and it built up. And then there was let's put together some kind of web-based Subversion browser, because you know, it's not efficient using just tools, that kind of stuff. So at no point, I think, really was there an opportunity to just put something new in. Also, well, I don't think we actually spent that much effort on it, to be honest. It was, not to overblow it, but there were 3 or 4 batch files that did the whole job. And the hard work was actually implementing the steps, and that's probably the message I want to get across. It's not that, you know, continuous integration requires this superb tool with lots of whizzy graphics. It doesn't. What it really requires is superb configuration management so that your scripts are correct. If they're not, you're dead in the water. It doesn't matter how often you build it. So we had to kind of put that together. And then the wrappers around it were trivial, and they're convenient for us. And like I said, I didn't want to put this stuff on developers and testers' machines if they had to debug it. I didn't want to create the build guy, as it were. So that was the rationale, be it right or wrong, but ultimately, if we're actually looking at the amount of effort expended, it's trivial. Yeah? And always we had them in mind is that let's create all these parts relatively loosely coupled. So if you change your mind, go for it. Yeah? For instance, now there's a commercial product which is very good at integrating subversion browsing with bug tracking. Yeah? That's now shining a light on the separate subversion browser and the separate bug tracker. Wasn't available even, I believe, 18 months ago. So we kept it lightweight and flexible in case we changed our mind. And we hadn't spent that much time. So I don't think it's a big deal.
I hope that answers your question to some extent. Any more questions? Yes.
Right, so you're allowing people to check in broken like code that will break the build. One of the discussions that we've had with our team is having some type of script or something that will allow you to test even before you check into Subversion or Perforce. Have you had any insight into that, or has anyone in the audience?
We actually did have that. There was
Pre-commit builds, yeah.
we didn't have pre-commit hooks per se, or
These are builds prior to a committee.
yeah.
If you check in broken code, it's too late.
Oh, absolutely.
It's just the wrong model.
That's the other thing. The
Yes, we were not checking in the broken code. We were having, we were testing before, we were checking the build is compiling at our end because, again, these compilation of these builds were just one-click batch files because it wasn't rocket science. So once you've made some changes, just click that button. And even as a tester, I could make in changes, click that button, and would see if the changes that I have made has compiled properly or not. And that's what we were testing before committing in the changes. And then then again, the automated tests were kicking off.
yeah, all this stuff was deliverable to everybody in the company in principle. Yeah.
So there were never bad bills?
Oh, there were bad bills. Yeah, because people sometimes just wouldn't do it.
What are the safeguards? What are the safeguards to build before they go on to testing? What if your build fails? What do you do?
Well, the build files, there's no executables, so that kind of solves that problem, really.
So,
you need to
yes.
get back to whoever made that mistake and work out what has happened.
Exactly. If the build fails, as Patrick has mentioned, there were no executables, there were no, and even if the markers were being copied and then the tests were failing and we were getting the result back. So, yes, the tests, yes, the tests were notifying us that something has happened. Yes.
So why not stop it before it even gets to
Yes, in the ideal world, all the people who were following the practices were doing that. That is, checking before committing it. But it's the ideal world. We find some lazy person or lazy developer or lazy tester just committing anything and then could break it.
Why you design a system to make that systemically impossible to happen?
or unlikely?
Less likely.
If they can check in code that breaks the build, you didn't design your continuous integration system correctly.
And we use Maven for that stuff, and it has little pointy things, but
Yes.
once you get it rolling, and every developer has to then build on
Yes,
it.
Maven is great for Java-based applications and web-based applications and
I don't think I've been clear enough, actually. The continuous build and the build developer did on the machine, yeah, identical steps, yeah? The only missing link is that when people just don't do the build locally to confirm that it works. But there's still the issue of missing files, yeah?
Yeah, or if they break the build for any other reason and the assembly line stops, it brings attention to them. They won't do it very often.
That's what happened.
I must tell you, we are having Hudson right now in the place where I'm working, but still we are having builds failing. Still we are having developers who are checking in the code. So it's not, and Hudson is, as you mentioned, is a continuous integration system, which is already. Yes, so it's a problem which is existing everywhere. It's just a matter of practice, and it's the process that you're using, and it's the discipline that a developer is having. So even it doesn't matter what tool you're using. If you're not having that discipline at an individual level, you're going to have problems.
So Team into it. It does the whole test scenario that you're asking developers to do by hand, and then and only then does it check in your code into the main branch.
So yes, TeamCity have not
It
changed.
basically enforces the thing that you're trying to do manually, and it's a losing strategy to depend on human behavior to make change happen. I mean, humans won't change.
You also, however, have a problem, a political problem, in that you'll have a number of participants in the process who all have different interests, and each of them will define what a broken build is differently. Now, maybe you get it right, maybe you don't. The consequence of not getting it right can include 2 or 3 weeks of no development getting done. I know of an example where that's happened. Somebody set up a pre-commit rule, and the existing code base did not comply with that pre-commit rule.
So it stops.
Here you go.
And it stopped the world for 3 weeks. Not just the project, but everything the project touched. Dead in the water. Don't have that mistake.
The title of the talk is Simple Tools.
Yes.
And there are multiple viewpoints. I think our message is that you said people don't change. Well, I disagree, because actually people did raise their game.
Yes.
And there's 2 reasons for this. Because it was obvious what was going on. Okay, so we've supplied the tools so that people could avoid embarrassment. And after a while, they started using the tools to do that. Okay, nobody had to go over the big stick and beat over the head. That's one thing. The second thing is that increasing the visibility, the transparency by making things simple, allowed the people that were interested to learn what was going on, to think about it, and to improve the process themselves and start contributing more. So rather than having a great lever that squashes everybody down, these ad hoc builds and let's struggle to get it out, you have the opportunity for the people that are more productive to go up to a higher ceiling. I think that's one of the messages of continuous integration. And yeah, you're right. If we did it again, we'd probably replace some different stuff. There's much better tools even now, just a short while later on. But the real big difference is that this stuff with the same team makes a difference. Yeah. So if you've got innovation like that, think it through and see what difference it makes.
Just to add to that point, I would say it's not the tools that are important, it's the habit which is important. Because just as I always say, like brushing is a habit. It's not important what brush you're using. Even you can do it with the finger if you have a habit of brushing. But so similarly, it was our aim to get the people into that habit of, first, because it started little, first try to introduce Subversion, make the people familiar with these things, then, just build a system around it so that they have simple batch files that they could build it automatically. And then we could have some automated tests running on the VM machines. And then we thought, okay, why don't we integrate all these things? So it was just a matter of putting, getting the people into that habit of checking in their code, getting the automated tests running, getting the response back. And once they're in the habit, then you could definitely replace with the good tools or even much better tools which are available in the market. So the idea is not to just throw away the entire big bag heavy client server application to the people who are already not into the habit of using the best practices, but to introduce little things which could improve or make your life easy, and then move on to bigger things, and then maybe replace it altogether. So it's tiny steps that you have to take towards better quality. That's why the title of the talk was Simple Tools to Fight the Bigger Quality Battle. So the quality battle still continues. It's not that we have conquered it, and you will never ever reach a position where you're going to conquer this battle. No, never. Because every time you come up with certain thing, then you'll find, hey, this thing was missing. Then you'll have new tools coming in the market. So the idea was getting the people into the habit of checking in their code, introducing continuous integration.
Another thing that we did that we kind of made it fun and to get around the politics of it, that we had some stuffed animals, or they gathered into a big group. So every person that broke the bill, the last person that broke the bill would take all the animals, and they had to sit in their office with all these animals until the next person broke the bill. So everyone was always waiting for the next person to break the bill. And it became teamwork. It became a lot of fun.
Yes.
The whole
So yes,
social pressure thing has to be done quite carefully, actually. Thanks, Ian.